Okay, solve the following circuits, or sometimes they may ask you to find the power dissipated in the 20 ohm resistance. Then it simply means find the voltage across this resistance V and find the current across this resistance and multiply the voltage and the current to get VI. Okay, so that could be one way of asking the exact same thing, solving for the circuit. Okay, so the first thing we are going to do is to, so let's see, let's call this I1, let's call this I0, and I'm going to define some currents. I'm going to call this current, and I'm going to make these definitions. I2, okay, the current through the 13 ohm resistance, I'm going to call that as I2, okay, and this current, I'm defining it to be I3. Okay, so pay attention to the fact that these are the definition and directions that I am giving. I'm choosing these voltage and current directions, and as long as I'm consistent with these directions and this polarity throughout the problem, it will lead me to the right answer. Okay, so the next branch current that I'm going to look at is this guy, the current through the 8 ohm resistance. I'm going to call this as I4. Okay, I'm going to call this as I4. So my idea, the idea is I want to be able to find out the total current that is supplied by the power supply, the voltage source. Let me call this as I source. Okay, so I want to be able to tell the value of I1. I want to know the value of I2. I want to know the value of I3 and I4. Okay, what are the values here? Okay, what are the different values of I1 to I3? That's the idea of solving this circuit. Okay, so the first thing we are going to do is this guy. Identify some nodes. Let me call this as node. Okay, let me call that as node A. I'll call this as node A. Okay, I'll call this guy as node B. That will be my node B. Okay, I'll call this guy as node C. Okay, and then this guy as node D. Okay, later on we'll come back to define node D to be ground at a later time, but for now, we leave it like that. Okay, there are 4 nodes. Okay, and then we'll come back and do some more okay, let me see if I can. Okay, node A, B, C, and D. The first thing I'm going to do is to solve this circuit. The first thing I'm going to do, solution, is to set up equations. Okay, the first thing to do is to apply KCL, Kirchhoff's current law, at node A. Let me apply KCL at node A. Okay, KCL says, like I mentioned, look at all the currents coming in on one side. Okay, the current coming in is IS, okay, from top to bottom, and equate that to the currents leaving, I2 plus I4. Everybody with me?
Yes.
Okay, so that's the step 1. The next step I'm going to do is to apply KCL at another node. Okay, so apply KCL at node B. Okay, this is all in an effort to find all the unknowns. I have 4 unknowns or 5 unknowns. I need a bunch of 5 equations. Let me not forget this guy, I naught. Okay, there's an I naught as well. So there's more than 4, 5 unknowns, I naught. I should be able to calculate a value for that as well. Okay, so KCL at node B, when I apply KCL at node B, that's this node, I have to look at the current coming in. What's the current coming in here?
At node B, the current coming in is I2.
Current coming in is I2. And what's the current leaving?
That would be I3 and I1.
Thank you. Okay, so I have KCL at node B. Let me apply KCL at node C as well. So I apply KCL at node C. There is 2 currents coming in. There is I3 coming in from left and I4 coming in from the left on the top, 8 ohm resistance. So I3 plus I4 equals to I2. I naught is the current going up, going down, right? I naught. I naught is I3 plus I4. Okay, so let's do KCL at node D as well.
你看贵州
KCL at node D, the currents coming in are I1 and I0, and the current leaving is IS. Okay, so the current leaving is IS, that is equals to I1 plus I0. Everybody with me?
Yes.
Okay. So now what we can do is in the problem, I think, and I have forgotten to mention that I naught has been given to be 2 amperes. I naught has been, sorry about that. I naught has been given to be 2 amperes. I naught is given to be 2 amperes. And we should be able to do the calculations. We have 5 unknowns, okay, including IS. Okay, I1, I2, I3, I4, and IS. Okay, we have these 5 unknowns. We need 5 equations. Okay, so we better set up one more equation. Sometimes it may be that these equations are dependent, and these equations we end up needing one more extra equation. Okay, so in order to do that, this is what I'm going to do. I'm going to apply KVL around loop alpha. Okay, so I'm going to define a new loop here. So before I do that, let me color code them carefully. Okay, I'm going to change them to this color. Okay, nodes, just so it doesn't overlap. Now I'm going to come back and define a loop here. See? Let's call this loop alpha. Okay, let's call this loop alpha. Let's call this loop alpha and try to, you know what, I think I better copy this and write it out in a separate page. Okay. That way it's cleaner. Okay. All right. So I'm going to apply, this is called loop alpha. I'm going to apply KVL around loop alpha. So the idea is to begin at the lower left corner. Okay. Begin at the lower left corner, follow the path, and add all the voltages that you come across. That's the idea. Right? So let's follow the outer path. We begin at the 80 volts power supply, and then when we begin our journey, we see a negative sign over there. So negative 80 volts. Okay, and then we continue our journey, and then we see a positive sign over there. So 8 ohms times I4. Remember the Ohm's law. The voltage dropped across this resistance. Because I'm using KVL around loop alpha, I want to add the voltage drop around the loop. And the voltage dropped around the loop is V times I. Around this 8 ohm resistance is 8 times I. Then I do this. Then I look at plus minus 6 sign, 20 ohms times I naught, the value of which is given to be 2 amperes. Okay, all of that equals to 0. Okay, I naught is 2 amperes. So I can write it as an equation. So from here, I naught is 2 amperes. I can get a value of, so when I plug in a value of 2 amperes here, 2 amperes here, the only unknown is I4. So I4 is going to come out to be, let's say, 5 amperes. Okay, I4 is coming out to be 5 amperes from the KVL loop. Okay, we'll use another loop. Okay, we'll do another loop, which is this guy. Okay, that loop over there. Dang it. Okay, that loop. Okay, let me call this loop beta. Let's apply KVL around loop beta. Okay, when I apply KVL around loop beta, I begin at the lower left corner. Okay, begin there, lower left corner, and follow the path. Okay, follow the path. Remember, this was positive and this was negative earlier. So when I follow the path, I see a negative sign first. Okay, so negative 4 ohms times I1 is the voltage dropped across that resistance, 4 ohms resistance, followed by I3 times 4 ohms, positive sign, plus I naught times 20 ohms is 0. Okay, so I'm following the path here to the starting point. Does that make sense? I
Yes.
naught is given to be 20 amperes. Okay. So from this, we should be able to rearrange these equations. And then if you solve the currents here, okay, if you solve the different currents here, if you solve these different equations, so let's see, let me do this. Okay. Okay, so I4 was found to be 5 amperes. And if you solve these equations, 1, 2, 3, 4, and 5. Okay, if you solve all of these 5 equations together, it's very straightforward to get the value for I1, I2, I3. So when you solve that, you should see a value for I1 equals to 7 amperes, and I3 is negative 3 amperes. I4 is 5 amperes. Okay, so on and so forth. I2 is 4 amperes, and IS is 9 amperes. Okay, so one quick way to check this is 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 the current coming in 9 amperes should equal I2 plus I4. I2 plus I4 is 9 amperes. That's the current coming in. So current leaving. Okay, so these are the values that you should get. When you solve this simultaneous system of equations. Okay, so when you solve the system of simultaneous equations, 5 equations, you get a value for I1 through IS.